Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/41 for the session October November 24. And we are going to solve question number 6, which is a particle of mass 1.2 kg is placed on a rough plane which is inclined at an angle of theta to the horizontal, where sine theta is equal to 7 over 25. The particle is kept in equilibrium by a horizontal force of magnitude p Newton acting in a vertical plane containing a line of greatest slope. See the diagram. The coefficient of the friction between the particle and the plane is 0.15. Find the least possible value of p. Very interesting question. This question is not only interesting but also one of the most important questions containing the fundamental concepts of mechanics. Well, before moving on to the basic solution, first of all, we'll have to complete the diagram. Well, let us complete the diagram. Yes, all the forces along with their direction can be drawn. So first of all, normal reaction, okay? This is our normal reaction. And weight is, okay, let me try to draw more appropriate. And weight is moving downward. Well, okay, then this is our angle. This is also theta given. After that, look at this. P is acting on the particle. So it is just, as it is pressing downward, we can just write below the line. Well, so it is a right angle triangle now. Yes, it is a right angle triangle now. This is a 90-degree and this angle must be theta, and it's now P. Okay. Well, after that, let me erase the unnecessary parts. Yes. Then we should not get deviated from the question that the surface, the plane is rough on which the particle is kept in equilibrium. The plane is rough. So whenever a plane is rough, first of all we should know the normal reaction. Okay, so let us find the normal reaction. What is the normal reaction? We know that r plus upward force. Let's see what is the upward force over here. Is there any force acting on the particle upward? Not at all. Look at this. P is also pressing downward. P is also pressing downward. So there is no force on this particle acting upward. So there is no upward force. That's why R plus 0. For upward force it is 0. Then the downward forces. So first of all, downward force is what? This weight is causing downward force. No, we made a mistake while drawing this figure. It should not be like this. It should be something else. Let me erase and draw it once again. Okay, it will be, just let me erase this part. This should not look like this. Okay, it will look like this. Then this is the weight. Okay, so our right angle is over here. I think you got my point, that weight is acting vertically downward and particle is trying to move down horizontally. Okay, well, so from this one, if we calculate our normal reaction, as I have told, P is also pressing the particle to the downward, so there is no upward force at all. So downward forces are what? First, weight is mg. We know how to write this, mg sin theta plus p is also acting downward. I mean pressing the particle downward. So it's p downward means this is sorry, again we made a mistake. It's not mg sin theta. Weight is not mg sin theta. Weight is always mg cos theta. So let me rewrite this. This is mg cos theta. Mg cos theta. So let me write mg cos theta and p sin theta. For p, the direction is this one. So it will be p sin theta. Well, then our r is going to be r. Mg is 10 into acceleration due to gravity. Mass is 1.2. 1.2. Then cos theta, we will have to find sin theta. Sin theta is given, look at this, if we draw a triangle like this, yes, okay, now they have given here theta, and sin theta is given 7 over 25. Sin theta is 7 over 25. So this is 7 vertical line and hypotenuse is 25. So what about our horizontal line? Horizontal line is going to be 25 square minus 7 square. Let us use our calculator. 625 minus 49. 625 minus 49 is 576. So 576, square root of 576 is nothing but 24. So our cos theta is 24 over 25. 24 over 25 plus p cos theta. P sin theta. Sin theta is 7 over 25. So 7p over 25. Finally, our normal reaction is going to be it is going to be 10 into 1.2 12. So 12 into 24, that is 288. 288 over 25 plus 7p over 25. So this is what our R normal reaction. Now we have already got our normal reaction. So whenever you are given a plane which is rough, first of all we will find the normal reaction. Well, then they have told us to find the least possible value. So what does least possible value mean? Least possible value indicates that the particle was naturally was supposed to move down. Look at this, particle was supposed to move down. It was supposed to move down to this direction, okay, to this direction. But all the forces including external p are stopping the particle from sliding down. So least possible value means all the forces together including the external force are trying to stop the particle from moving down. So it is actually the particle is supposed to slide down, and we know that the concept we use in such case is the motion law of Newton. So what is the concept of the motion law of Newton is driving force minus resistance force is equal to mass into acceleration. Well, so what is our driving force? We have already explained that driving force is nothing, only the weight is causing or trying to slide it down. So weight is only the driving force. So let us calculate weight. How to calculate weight? We know weight is equal to mg sin theta, because we are, look at this, don't get confused here. Initially we have used that cos theta. Now why are we using sin theta? Cos theta was used for what? Look at this, for this one, the in term of this triangle, it was, let me show you, this direction. So this direction was actually, in terms of the triangle, this is horizontal axis. Now we are calculating weight is, I mean, the particle is sliding down like this one. So this is the direction, this is also the same direction, it is parallel to the horizontal axis. But in term of triangle, it is now vertical axis. If you look at the triangle carefully, you will find that this is vertical component. So vertical component of this triangle is mg. Let me erase this part after zooming it out. Okay, if I erase this, let me start just a little bit lower. Okay, so our driving force is nothing but weight. Weight is mg sin theta minus, we have already explained that all the forces including the external force is the resistance force to the motion. So first resistance force is what? P. P is trying to stop the particle from sliding down. So P, for P, what is the force? Now the direction is this one. Look at it. This is the direction. So for this direction, in term of this triangle, it is horizontal axis. So it is going to be P horizontal. For horizontal, we use P cos theta minus another force. The major force causing resistance to motion is the frictional force, and we know the frictional force is equal to mu r. Frictional force is mu r. Let us write mu r, and right side is going to be 0, because if we look at the question, the particle is kept in equilibrium, means there is no acceleration or motion at all. That's why right side is 0. So mg sin theta, m is 1.2 and acceleration due to gravity is 10. Sin theta has already been given, it is 7 over 25 into 7 over 25 minus 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 p cos theta. Cos theta is, already we have written, cos theta is 24 over this one. Cos theta is 24 over 25. So it is going to be 24p over 25, and mu is the frictional coefficient. How much is the frictional coefficient? Frictional coefficient is given 0.15. So 0.15 into r. How much is our r? We have already obtained r before writing our main solution. What was our r? R is equal to, this is our r. R is equal to 288 over 25 plus 7p over 25. Okay, so 288 over 288 over 288 over 25 plus 24p, sorry, 7p over 25. So this is our r, normal reaction, equal to right side is 0. Then let's do the calculation. If we do calculation, we are going to get, what are we going to get? Yes, it is going to be 10 into 1.2, it is 12. 7 12s are 84. 84 over 25 minus 24p over 25 minus, if we multiply 288 by 0.15, it is going to be 43.2. 43.2 over 25 and minus plus minus 7, if we multiply 7 by 0.15, it is 1.05. 1.05 1.05 p over 25, and right side is as usual 0. Okay, after that, if we isolate the p's, so it is going to be 24p over 25, then plus 1.05p 1.05p over 25 equal to, in the right side it is, I mean on the left side it will be 84 over 25 minus 43.2 43.2 over 25. Now if we look carefully, every denominator is common, I mean 25. So can't we dissolve this 25? If we multiply everyone by 25, it is going to be just 24p plus 1.05p. So finally it is going to be 25.05p. 25.05p equal to, here if we do subtraction, 84 minus 43.2, so 40.8, it is 40.8. Hence p equal to, hence our p is going to be, I can write just over here, hence our p is going to be p equal to, if we divide, that is 40.8 over 40.8 over 25.05, then it is going to be, let us use our calculator. Our calculator will show, let it not be the final step, we will write one more step. Hence our p is, hence our p is going to be, p is equal to 40.8 over 25.205. Let us use the calculator. 40.8 over 25.05. 40.8 over 1.63. 1.63 is the value of our p. Okay, and that's all about this solution. So what have we done? What are the steps? Remember, first of all, when the surface of plane is given rough, first of all we find normal reaction R, and before that also we should complete the diagram. It helps you to calculate the magnitude of the forces. Well, because we are going to apply the concept of the motion law of Newton where the components are forces. Well, then remember they have told us to find the least possible value of p. Least p means actually this p is pressing the, I mean, all the forces, along with P are trying to stop the particle sliding down, whereas only weight is the force which is causing the particle move down. So this is what least value. If they tell us for greatest value, then except P or external force, all the forces act as resistance to motion. I think for better understanding, you can watch my video of question number 5 from the paper 9709/42 for the session May June 24. In May June 24 paper, in 42 of May June 24 session, question number 5 was almost similar that, but that question asked for both the least as well as greatest value. Please practice that one attentively, and it's a very very important concept of mechanics. If you can continue practicing this, you must be able to know all the fundamental facts of mechanics. Well, then here you may raise a question: why is it that R is, there is no upward force? Why isn't there any upward force? The answer is here P is, look at this P. If you look at P carefully, P is just horizontal, I mean parallel to the horizontal ground. That means it is pressing the particle moving downward. Okay, I'm pressing downward. That's why there is no upward force acting on the particle. It is just all the forces are pressing it downward. The weight as well as P is also pressing downward. That's why that is the sum of the negative forces or downward forces is the normal reaction force. And as I have mentioned, you can watch the video of 9709/42 for the session May June 24 question number 5. That one was similar to this, but as there is a very delicate and crucial difference between these two, if you practice these two solutions together, you will understand all the facts related to this. And that's all about this solution, and thank you for watching the video and staying with me. May Allah bless all of us with the beneficial knowledge. Fi amanillah.